Yes, okay, great. My name is Mikael. I'm going to talk to you about LTTng and containers. I'm a software developer at FOSDEM. We're the company behind the LTTng project, so the main developers of this open source project. My background is in system administration, but also in development, and I do mostly CI, working build systems, and so on. And I maintain the LTTng packages in the So first, what's LTTng? Well, it's a suite of tools, mostly a kernel tracer, which I hope some of you are familiar with, and also a userspace tracer. Also, other parts of the project are the tracing file format, which is called CTF, the Common Trace File Format, which is used by all of the LTTng tools and also by other tools like JDB, for example, with its trace and, well, it's used in JDB. You can do also tracing in the same format. And also the LTTng project has a single command line tool, which is used to drive both the user space and kernel tracer, and it's also a library that can be used in other C applications and used through bindings through Python and other languages. And there's also a command line trace viewer, which is basically reads the binary trace formats and convert it to human readable text. And also multiple graphical interface, the user interface viewers like Trace Compass and LTTng Scope, which gives you the ability to go through traces, export them, run some analysis on them, do some graphs and other stuff. And then why would you use LTTng? Well, I won't try to explain why you should do the tracer, but I'll try to tell you why you should choose LTTng if you're looking for a tracer. It's very low overhead. It's been built to be used on production system, and it is today used on production system by multiple companies. And unlike some more traditional logging frameworks, which are comparable to tracing in some use cases, it can be enabled and disabled at runtime, so you don't need to restart or reconfigure your system. You can activate tracing and start it whenever you want without affecting the rest of the workload. And also there's a lot of flexibility in how you would store your traces. So the traces can be, the default mode would be to store them on disk, but also if you have like diskless system or systems with low storage, the traces can be streamed over the network. They can also be written to memory buffers and only snapshotted when you need to get the actual data, so the system can be running a long while without using any storage, and then just when you need the actual trace, you can extract it from memory. And then for the container part, well, what is a Linux container? I'm sure probably most of you won't be surprised to know that there's no actual concept of a container inside a Linux kernel. It's multiple subsystems like C groups and the namespaces that are combined to make different third-party implementations like Docker, Rocket, LSD, and many others. So supporting all this in a kernel tracer can be a bit complex since they use different ways of, each container technology has its own way of using those features. So the least common denominator in here is the namespaces, so that's what we chose to use as a first implementation of how we can integrate with containers in LTTng. So what's the current status? What can you do today with LTTng on a container host? So the kernel tracer can be used on the host. It needs kernel modules to be loaded. But there's no way to filter events per container, so you get like syscalls and all other kinds of events, but you cannot really easily match them to a specific container. And then for the user space tracer, it can be run inside the host, but it can also be run inside a container. You just need to run 2 instances, like 1 instance per container. But again, there's no information that would be, or you would be able to correlate like a trace from the host side with the trace from the user space inside a container right now. So how can we fix that today? Well, we have currently some patches where we add the support for namespace context. So what is a context? In LTTng, a context is basically metadata that you can attach to each event in the kernel. So for example, existing contexts are PID, for example. So when you get a syscall, you would add metadata to it to say which PID this syscall was issued from. And so we've added support for namespaces. So basically, you can now, when you get a kernel event, you can add, for example, the PID namespace to it, and then you'll know in which PID namespace the process that called this syscall was. And also, we have another feature that is called state dump. It's basically when you start tracing, state dump events will be issued that will basically give you a current state of the system. So another thing that we need to add is like a dump of the current namespaces that are on the system for, or the tree of namespaces for each process. So yeah, so those patches are currently not upstream, they're on feature branches. And yes, so for example, here I have the text view of a kernel event for a syscall, the getTime of the syscall. So with these patches added with the namespaces I just talked about, so we can see, for example, in green we have the PID-NS, which is basically the inode number of the namespace in the FOSDEM, because that's the only unique ID we can get in the kernel to differentiate one namespace from another. And then we can see other useful namespaces, which are the TID and VTID. Basically, the TID is the unique ID of a process inside the kernel, so like it's the thread ID in the root namespace of the kernel. And then the VTID, which in this case is the process ID as seen inside the namespace of the container. So in this example, we can see that the process is called Redis server, and its VTID is 1. So we can extrapolate from that we're running inside an application container, and that Redis is running as the init process, so an application container that doesn't use an init process. So in this case, it would be a Redis server Docker container. And then the state dump. So this state dump would give us initial state about each process that are running inside containers. So for example, here we have the systemd process, and we can see that its TID is 1527. So that's the asymptotic kernel. And then we get two PID-NS state dump events. So we can see that the namespaces are nested. So we see the first event as a level of 1. So this is the namespace of the container, and then the other one has a namespace level of 0. So that's the host root namespace. And we can see that the TID never changes between those because it's the unique ID, but we can see that the VTID will change. So in the NS level 1, it's the VTID of 1, and in the kernel side, 1527. So with this information, and we do the same thing for the user space tracer, which is all basically the same. And with all this information now, we are able to do some filtering. So we can start a tracing session and say, oh, I just want to trace the syscall that comes from this container. But right now it's not very integrated because we need to know what is the PID namespace inode number of our container to filter it. So you can, well, I don't know if you can see, but we can, with Docker inspect, we can get the PID from the init process, and then with LSNS, we can get this, the inode number of the namespace, and then using this information, we can create an LTTng session that will filter this, and the resulting trace will only contain syscalls that come from process in this container. So we're starting to get somewhere. But then it would be nice to be able to use like the container name, for example, instead of having to get the inode number. So to do this, we need a way to map kernel IDs to human-readable names. So right now, the easiest solution we found was to use a small, well, basically a shell script based on what I've shown you before that will iterate over all containers. So you need to write a helper for each kind of containers you're running on your system that will basically dump this information inside a user space trace that can then be combined with a kernel trace and then run through some analysis script, for example. And here we see that I wrote a basic implementation that outputs events, and you can see that we just get container name and the container type, and it's PIDNS that we can use to correlate with the events we saw before. And with all this, you can use analysis tools that we already have, which are called LTTng analysis, which are basically kernel, well, analysis based on kernel traces. So, for example, in this slide, it's probably not very readable, but this is a CPU top analysis. So it will take a kernel trace in input, and it will do a graph of CPU usage per process. But I've modified those, and you can maybe see it at the down on the slide where there's a bit of color that you can also now see CPU usage by container, and you can see the container name, its ID, and its type. So there's already a lot of those analyses that were provided by the LTTng analysis project, and they could all be adapted to be container aware. And we can see another analysis here. It's a memory allocator analysis based on page alloc and page free trace points in the kernel. So you could usually filter it on some condition, but now you can add container filter and see which containers layers on your system are doing page allocation and page deallocation. And so with those tools, a complete scenario would be to run a kernel and user space tracer on the host, so you can get kernel traces and get the state dump or the name resolution from the container runtimes. And then for the containers where you're running applications that you could instrument with the kernel, the user space tracer, you could also run one LTTng instance in each of those containers. The version could be completely different from the host system. So, for example, if your host is running an older version of Linux with a different kernel or whatever, you don't have to have the same version. So it's inside the container and outside of it. So for deployment, it's yet easier. And then you could stream all of those traces to a relay daemon, so over the network, and run some analysis offline to get the information you're looking for. So, and what next? So all the things I've shown you are not yet upstream, so we're working on merging this maybe for the next release, but we're not sure yet. Another thing that someone else is working on is adding the same kind of things for context and state dump for C group values. So that's being worked on and should maybe land in the following months. And longer term improvement would be to instrument container runtime so that we could get events about the lifetime of containers. So get events when a container is created, when configuration is changed, and all interesting information that could also be integrated into the existing analysis tool to give you a better view of what's happening in the system. And also add better integration with the existing command line tool. So for example, instead of having to type a big filter, you could just like use LTTng filter -- my container name, and the daemon would resolve the container name based on what's installed in the system, and so on and so on. So having tighter integration between the command line tools and the different container runtimes. But what we're most interested in is what do you need. So I would very like to hear about you guys what you are interested in, what your needs are, and what are your use cases. And finally, do you have any questions?
Okay. I've got 2 quick questions before they even more questions.
Yeah.
First question, what do you do with nested pid namespace?
Nested pid namespace?
Yeah.
Yes, well, in the state dumps, we get nested events for all so we can know what's the chain of the
PID. So you just fit on the top level right now?
I'm sorry?
You just fit on the top level right now?
Yes. So in this simple example, yes, but we have the information about the hierarchy of the PID namespace and also the user namespace, I think, which are also hierarchical.
Okay. The second question is about, did you see the current discussion around the audit container name that's going on?
I've heard about it, but it didn't seem to be mature enough yet to be something that's used.
That's fair enough. I mean, eventually we should have some kind of way of tagging containers in the kernel, so I'm assuming you're going to be using that at that point.
Yeah, well, but it's tagging, so it will probably be different for each container runtime. But yes, that's information that could be more easily, instead of having to use both the kernel and userspace tracer, we can use only the kernel tracer to get this information.
Right. Other questions? Yes.
So the third question is it feasible to do that, to repeat the analysis using another tracer? For example, EPBF or...
To use the analysis?
Yeah, to do the analysis using other tracer. I didn't get the own feature of LTTng to work with containers.
Well, I'm not sure. Well, if you can...
Can you do the same thing using just pure ADPF tracing or any of the other tracers in the kernel?
Well, if you can convert your traces to the CPF format, then you might be able to run the analysis, but that would imply that the event names and so on are all the same as for LTTng, so it might be a bit complicated.
Questions? Yes.
Apologies if I missed this, but what would be the point of running both the user space tracer in your container and also the host space tracer?
Because we want to maintain isolation between the host and the containers. And in between each container. So basically if you run, well, you could technically run the user space tracer on the host and have it processed inside a container. But, well, first, a couple of simple patches would need to be applied because there's expectations that are currently not met, but basically by mounting directory with the proper sockets inside of your container, it works, but the goal right now is to not break isolation, so it's totally doable to run a user space tracer inside the container, and also for deployment purposes. If you have like different distros in different containers with different libraries, it could get very messed up, so it's a lot easier to just have one user space tracer per container. But there's no technical, there's nothing that would prevent it in the end to do the one tracer inside of us.
Other questions? Or use cases? Apparently not. Well, all right, thank you.
Thank you.